Welcome to the session for the Ship in Operation SC. My name is Young Kim from Seoul National University. That we would like to invite the technical committee chair, Dr. Jimba Wang, to give a presentation. Presentation will be 20 minutes, and afterwards that we will have discussion for about 10 minutes. Dr. Wang, it's all yours now.
Okay, thank you, moderator. And this is Jimba Wang from MARIC. Dear participants, dear organizers, it is with great honor to represent Ships in Operation SC Committee to report to the full conference the most important progress during past 3 more years. First, I'd like to introduce SOS committee members. They are Secretary Florent from HSVA, Dominic from Southampton University, Hank from Marine, Sebastian from CTO, Kataku from Mitsui, and Kenichi from NMI, Hideo from JMUC, Sim-Yun from SHI, Gong Zheng from CSSRC, and Professor Strasser from AC. During this term, 4 committee meetings were held. First in CTO, Poland, second in Mitsui, Japan, third in HSVA, Germany. The last meeting was in Samsung Shipmold Basin, South Korea. AC representative to IMO, Professor Gerhard Strasser, attended all the 4 meetings to keep close eyes on the progress of the sea trial procedure, correlation guideline, and provide feedback from IMO MIPAC meetings. SOS has contacted CFD-EFD committee on how to proceed CFD-related issues, RNP committee regarding load variation coefficient. SOS also contacted Maneuvering in Waves committee and Quality System Group. A joint meeting was also held with CFD-EFD and RNP committee on a new method to predict delivered power using CFD and EFD, with the form factor from CFD, while other data from model tests. After face-to-face discussion, it was agreed to refer to research findings in relative final reports to full conference. From AC Chairman, SOS has got major comments from IMO MIPAC meetings. Either relevant method should be improved with sufficient validation, or a new method should be proposed. ITTC sea trial procedure 2017 version was accepted by MIPAC 73. IX 2014 guidelines shall be updated accordingly to reflect the new progress. Discussion on EEDI phase 4 and early implementation for container ships are far because they are far below the current baseline. Terms of reference after coordination with AC. Shallow water correction. To formulate, validate, and recommend a single method for shallow water effect. This task is considered the highest priority. During this term, work conducted includes CFD analysis, model tests, new water depth limits study. Conclusions from CFD analysis for KCS. The difference between relevant method and CFD method is within 3% below a water depth from number 0.675. Sinkage estimation has influence on this difference. Model tests results corrected with relevant. Shallow water test with wall correction and deep water test corrected to shallow water agree with each other quite well until 18 knots. After further study, SOS concludes relevant method provides more consistent and accurate correlation, thus is accepted by SOS as the only method for shallow water correction. New water depth limits have been set. For lower limit, it was updated and replaced square BT by T. This is more scientific. for upper limit, cancel to keep continuity of water depth correction. Wave correction, more extensive validation on the present methods, and introduce other methods when necessary. It is observed wave added resistance outside 45 degrees from heading cannot be ignored. This is an example of a large container ship from motor test. At ballast, when wave angle is 60 degrees, 5.4% R wave observed. This is very remarkable. In fact, even at a stern cautery, still over 2% R wave exists. At full load, almost the same situation as ballast. In ITTC trial procedure, it has clearly specified the ship should head into dominant wave or wind. However, for large vessels such as VLCC, VLOC, 1+2+1 double runs could last about 10 hours. During this period, wave direction is likely to change over 45 degrees. While iterative method is often used, the head required unchanged. This is the first situation. Another situation is when angle between wave and swell are large and both have to be considered. Another situation is when angle among wind, wave, swell are over 45 and the wind is strong. For such kind of case, we will have chance to encounter wave angle larger than 45. Unfortunately, present empirical method can't deal with above situation when ship lines not available. Thus, it is necessary to develop a new empirical method to cover wide wave angle when ship lines not available. Development of the new method was joint effort from Chopra, NTUA from Athens, NTU from Singapore, and America from China. The new method was on the basis of Fortinson and J&F formula, with two important improvements. B over T, speed, wave heading are introduced to better capture peak position, to better simulate motion effect, while partial reflection and finite draft, length of entrance and run, trim and draft, flare are involved to better consider reflection effect. Experimental data about 130 ships and 3,000 data points are used for development and self-validation of the new method. Open validation in SOS on typical commercial vessels, bulkers, tankers, and containers. In the first region, from 0 to 45 degrees, generally, the new method agreed with motor test at different angle, although slight underestimation in short waves was observed. While on another region, from bow quartering until following, the new method agreed with motor test at different float number, different wave angle. Open validation on other vessels, such as cruiser, RoPax, ANGC, PCC, etc. In the first region, from 0 to 45 degrees, the new method generally agreed with motor test, while on the other region, from 45 to the following, the result is acceptable. From the open validation in SOS, we can see from the table, attended correlation coefficients are 0.86. This is much higher than agreed ones. And also from the figures, we can see data points are almost equally distributed beside and close to red bold line, which suggests bad correlation factor. As to voluntary validation, attendant coefficient is 0.94 in the whole range. This result is quite encouraging, and the relative error has a Gaussian distribution with average near 0, and 75% of sample points are within 2% interval. Summary and conclusion on this new method validation. On March 16, An AC meeting was held to discuss about the method. After further discussion and voting, AC agreed to include the method into the C-trial procedure, thus to make the procedure more complete, competent, and valuable. Monitoring the development of CFD method for wave editor resistance, the purpose is to review the state of art of CFD for the prediction of editor resistance. This is a summary of examining the CFD cases on different shape type, different color, at different wave direction. This is an example of CFD comparison with model test on two typical vessels, KVSCC2 and KCS at head wave. From the comparison, we can see relative differences of non-dimensionalized editor resistance is within the range of 10 to 40%, while the absolute differences are of similar magnitude for both shorter and longer wave cases. This is the experimental data of all headings available. We have S175, KCS, ETC at different speed, at different model length from different model basin. Generally, open tester data with geometry is not enough for CFD to compare. Thus, to have high fidelity test data of different hull form from different facility are important. Guidance on the location of anemometer, high as can above decks, above front edge of bridge, and the scenical meter is preferable. Ideally, remote measurement free from superstructure should be used. This is a comparison of meter location and the fitting process. After filtering, we can see influence of meter position seems not so significant, with a difference of 0.02 knots, while influence of meter type is 0.04 knots maximum. And wind average process with and without from actual meter is minus 0.02 until minus 0.07 knots. So actual meter is recommended, and the expected difference between averaged and each run is minus 0.04 knots. This result is consistently negative. Limitation of averaging wind correction method. When wind speed is close to the ship design speed and the angle is small, averaging accuracy reduced over double run. While wind speed reaches BF5, BF6, almost all commercial vessels underpredicted. Conclusion from the study, wind average method over double run still remains because of imperfection measurement caused by superstructure and inaccuracies of instruments such as copper type. However, correction on single run may be used in case two subsequent runs are stable or undisturbed wind speed is measured remotely. Establish guideline for CFD to get wind coefficient. This is a completely new guideline, which includes two parts. The first part is general practice for CFD approach, while another part is general methods of evaluation. Two cases are used for benchmark study. One is HSBC from CTO, another is JBC from NMRI. From the comparison between CFD and wind tunnel test, we can see for HSBC, the difference is about 25%, while for JBC is about 20%. Averaged wind velocities as representative wind velocity are used here. We are surprisingly to find for both JBC and HSBC, RMSPE of CX remarkably reduced after using averaged wind speed as reference. From the right figures, you can see this. Current correction, possibility to use long track. It is proved to be premature at this stage. For power correction and direct power method, shaft rate can be derived with the following formula. You can see theta v has taken away due to steeping Lacan-B method when compared with 2017 version. Influence of water temperature on speed. Two theories are studied, and the conclusion is the speed correction is about 0.02 knots per 2.5 centigrade. Noise in the measured data and the measurement error. Dominant component is from shaft power, which contributes 60% of the total uncertainty. So shaft torque should be measured more precisely. Updates of the C-trial procedure and also compare with 2017 version. First is wave correction method. A new method SNM introduced when wave angle larger than 45 and ship lines unavailable. For shallow water correction method, only Raven method retained and only resistance corrected. For lower limit of shallow water, it was updated. For upper limit of shallow water, this cancelled to keep continuity. For wind correction method, occasions added when single run could be used. For additional double runs for sister ship, it specifies when mean of means and deviation is greater than 0.3 knots from the first ship, then the same procedure as the first ship should be used. Motor ship correlation factors at different depths. This focused on form factor, submerged transoms, flow separation, and effects of trim. With following updates, more detailed description of iterative approach, an Excel sheet was provided for testing, and required size of samples were recommended. For key performance indicators, ISO 19017 is a very important standard. Threshold values are essential because derived speed-power relationship is very sensitive to this value. So it is vital to be transparent and consistent. More accurate measurement of environmental data. Comparison of wave radar with forecast and observations shows clear difference. You can see circles here. And comparison of wave radar with hindcast data also shows large difference. So wave buoy close to the ship is desirable to check wave radar to ensure the accuracy. Multi-layered Doppler sonar is also useful to measure speed through water. While thrust and torque monitoring is helpful to separate the hull and the propeller performance. Speed power analysis on a single run on VLCC, corrected monitoring data and design estimation agree generally well in bow waves. For PCTC, we almost can get the same conclusion. So this study on a single run is worth to continue in the future. Monitoring the ICT technology, LIDAR laser scanner is a promising technology which could be used for wind measurement. Main conclusions here will be very brief. First, the Raven method was accepted exclusively as shallow water correction. For shallow water testing, it needs tank wall correction. This is very, very important. From the benchmark study of CFD for wave added resistance, it shows deviation from tests is about 20%. A new wave added resistance prediction method was developed and included in the C-trial procedure. Limitation of averaging wind correction method identified and averaging method kept due to the influence of structure, etc. New guideline on CFD-based wind resistance coefficients has been made, and guideline for derivation of correlation factors updated. Speed power procedure has been further updated to reflect all research findings so far. Recommendation to the fall conference is one procedure, two guidelines is expected to be adopted. My recommendation for future work, first is address issues related to surface roughness at full scale and provide technical support to ISO and IMO when updating files such as ISO 19030, ISO 15016. Address aspects of speed power, procedure, and update. The last is to study and update two guidelines on motorship correlation factors and on CFD-based wind coefficient. At this moment, I'd like to express my heartfelt gratitude to SC for great support and guidance, especially SC Chair, Professor Strassel, Secretary Ober, and G2 Chair, Dr. Leszek. Thanks also go to development team of shallow water and wave-added resistance correction method, especially Dr. Raven, Professor Papanikolaou, Dr. Liu, Dr. Feng. The most important thanks should go to all SOS members for the joint and sustained efforts. Well, I'd like to stop here. More detailed information, please refer to SOS committee report and the PPT on the website. Thank you all for your attention.
Okay, thank you, Dr. Wang. And we have two written discussions in through the website. Well, I don't know if you can see, but I will read.
Okay.
And from Guillaume, the chair of the managing committee. And what is the doubt on the physical background of square root of BT? It represented the cross section of the hull. This ratio to the ratio of a tank or a channel across a section is important.
Yes, where can I find the question?
Actually, I'm trying to show the
I will stop share first, and your turn.
Okay. Actually, I think I can see the question, but I don't think it goes to you. But it's written during your presentation. I will say, I will read again. Okay. What is the doubt on the physical background of square root BT?
DT?
Square root B multiplied by T.
Okay.
Yeah, you can see the chatting.
Yes, I see this. Okay, I will make a brief introduction on this. In our 2017 version, C-trial procedure, we use 2 multiply square BT, where B is the breadth of the ship, T is the draft. We use this parameter as the low limit of shallow water, while 3 multiply square BT as the boundary from shallow water to deep water. After the discussion in SOS, we found this parameter is not so scientific. So during this term, we changed square BT into T, just the draft. However, and also we introduced another parameter is VS power 2 over G. We think this is also very important part. Yeah, so the new version, 2021 version, we have changed this, try to make it more scientific. Yeah, I wonder whether this answer is clear.
Okay, we have one more question by Hans Huisman. Sometimes the window averaging is not needed anymore when after averaging shows that difference is low. This is a new statement. I don't see any scientific justification in your report.
Well, as to win averaging method, well, first I will give some introduction. I believe some other members can make some supplement. Yes, win averaging method has been discussed. If I am correct, because I have been in 2 terms in PSS and 1 term in SOS, we have discussed this issue about 9 years. This is really very sensitive and quite relative complicated question, although it looks not so complicated. After our further discussion, we conclude we still keep it. I mean, averaging method is still used just due to 2 reasons. First is usually on-board meter will be influenced by superstructure. It is not so easy to avoid this. The second reason is about the accuracy of the anemometer. Usually, of copper meter is often used. So in this way, first it was influenced by superstructure. Another, its accuracy cannot be ensured. So from this sense, we still kept the average. However, we also open some cases when single run could be used. That is, if you say within the double run, for the subsequent run, if the wind is very stable, you still can use a single run. And also, if you see remote measurement is used, you also can use a single run. Okay. Any other members can make some supplement on this?
No, it's okay. It's okay.
Okay,
I think
fine,
it's a time. Yeah, time is up. So I would like to sincere appreciation to the committee members, and you had a very good contribution to ITTC, and I also thanks the 2 discussers. So we have to close this session. Thank you, everybody. Thank you, especially Dr. Wang. Yeah, thank you.
Thank you very much. Thank all. Okay.
Thank you. Yeah.
Okay.